Today we're going to do the iodine clock reaction, which consists of reacting the bisulfite ion with iodate, and it's going to produce sulfate ions, iodide ions, and some hydrogen ions. This is the slow reaction. This is going to be the rate determining step. However, what happens is you're going to end up with somewhat of a loop, and you'll see what I mean when I get through this. So some of the product that you make, which iodide ion, is then going to react with some remaining iodate ion in solution, producing iodine. When you add, and this reaction happens much faster, so it doesn't really impact the rate of the reaction. When you add these up, you get this for the total equation. So what also happens, though, is some of the iodine molecules produced can then react with the bisulfite, so you end up consuming some more of that reactant. And then it will produce the iodide ion, sulfate and the hydrogen ion. So really what you have is bisulfate and iodate producing iodide. The iodide then reacts with the iodate to produce iodine. Then the iodine reacts with remaining bisulfate ions in the solution to produce iodide and sulfate. However, once all of the bisulfite is consumed, you no longer have the possibility of this step occurring. And you end up with iodine left over in solution. And iodine, when that's in the presence of thiodine, it's going to produce a nice brown complex, just like starch. It's going to be starch. So what we're going to do for the experiment is we're going to keep a constant concentration of bisulfite, and we're going to vary the concentrations of the iodate. So basically, you're going to, in the first well, you're going to put 1 drop of the iodate solution, 9 drops of distilled water. Then in the second one, you're going to put 2, and then 8 drops of distilled water. Then 3 drops of the iodate, and 7, and so forth. And then you're going to keep 10 drops of the bisulfite ion, and you're going to add them together. So what you're going to basically be doing is determining the order of the reaction with respect to iodate, because you're keeping the bisulfate ion concentration constant, and you are varying the iodate. So you're going to plot a graph of 1 over time, which is going to essentially be the rate of the reaction versus the concentration. If the concentration of iodate has no effect on the rate, you're going to end up with a flat line. If you end up with the concentration having a linear effect, meaning like if you double the concentration, you're going to double the reaction rate, you should end up with a linear function. And then if it's a second order reaction, what you should end up with is an exponential growth when you plot rate versus concentration. So you're going to determine which of these applies to the iodate concentration, and that will be able to establish a rate law.